Hey guys, I'm showing you a video to explain the steps that are in the project task 8. So I've opened my Google Sheets project file, and I don't need to open the 8.3 notes, but you probably should. I'm going to put one new worksheet in my Google Sheet and name it Task 8. Okay. Now I'm going to go to that first state I was assigned in task 7, copy column H, which is height, into column A of this new sheet here, and column J, which is arm span. So H and J. My first state was Tennessee. So I'm going to go back to Tennessee. I'm going to go get column H, which is height in centimeters. I'm going to do a copy. And I'm going to go into the task 8 sheet and paste. All right, now I'm going to go back to Tennessee and I'm going to go to column J and get arm span with a copy paste. So I've got A and B filled out with height and arm span. Now I'm up to the fix any errors or blanks that I see. So I noticed that whoever took the survey right here in row 4, this is for me anyway, they didn't answer either the height or arm span. So if I'm going to delete this row, I clicked on the number 4 and I'm just going to, on the edit drop down, delete row 4. Now I notice someone put in 5 feet 10 inches, so I'm going to convert that to centimeters by asking Siri on my phone. Hey Siri, convert 5 feet 10 inches to centimeters.
5 feet 10 inches is equivalent to about 178 centimeters.
Okay, Siri told me it was 178. Okay. Somebody here put 58 and 55 for height in centimeters and arm span in centimeters. I'm just going to have to delete that, unfortunately, because those don't seem possible to me. So I'm going to delete row 8. Okay. Next, someone put 80 for their height in centimeters and 181 for their arm span. Again, I just have to make a decision here that doesn't make sense. All right, scrolling down, someone who put 83s in for height. There's no way someone's 83 centimeters tall. So I'm going to delete that. I have another blank row. Okay, and then back here I see also that there's an 83 and an 83. Okay, so this is cleaned up. So over here, I noticed somebody's arm span was entered at 75. Again, these don't really make sense because, guys, 5 feet is, already somebody who's particularly short. And arm span tends to kind of closely mimic height. So a person should not be only 75 for an arm span. Now I can't just delete that 75 because then if I just delete the 75, these guys will all move up to fill that space in, and now all the pairings were going to be off. So if there's any mistakes, whether it's in the height or the arm span, I either have to fix both to keep the row or delete the row. All right, so I only ended up with 15 measurements that make sense to me. Notice that although I have filled into row 16, I know the size of my data set is 15 because there's headings in the rows. Okay, so that fixing took a while. Now I'm interested in a claim that a person's height tends to equal their arm span on average. So in order for me to analyze that claim, I'm going to need to calculate differences. So the remaining work on this activity, this project task 8, is going to be on difference. So I'm going to put in a heading of diff equals height minus arm span. And then I'm going to calculate those differences. So equals A2 minus B2. It's going to take those two entries and subtract them for me. Okay, and then if I grab the little square, I can fill in the remaining cells. So I got those differences calculated out for height and arm span, pasted it down, and now I'm going to make a histogram of this data. So I'm going to highlight column C, and on insert, I'm going to pick chart, and let's see what chart it makes for me. It picked scatter. I don't want scatter. I just want a histogram. Okay, so I'll just see what the default histogram is that they made for me. And I'm going to have to move that out of my way and make it a little smaller because I need to do other things. Let me just move that over here. So I asked you to make some observations on this. Based on the histogram, does it seem like the heights are generally equal, less, or greater than arm span? And how would I know? So I'm looking for the value 0, which would just be a little bit here. And I noticed that I got a lot of positive differences, way more than negative differences. So I would vote on average that I seem to have people whose heights are greater than their arm spans because I got a lot of positive differences. Right? And then is my distribution of differences, what shape does my histogram have? Because I'm going to do a t-test on this, and I'm supposed to be convinced that the data could have come from a normal distribution. I certainly don't see a bell curve here, but because I don't really see strong skewness or outliers, I'm not worried that this does not look very normal at all. Okay, so that's why I asked for the graphical display, just so you could get a visual about, are my differences looking positive or negative or close to 0, and what the shape is of that. All right, so I don't need that histogram anymore. Now I'm going to need some summary stats on these differences. So please follow these exact instructions of where to type. So I said starting in cells E1 to F4, type this stuff. Well, E1's empty, so I'm in E2 typing mean, standard deviation. It's okay to abbreviate that, and sample size. And then over here, I need a heading here, diff, where I'm reminding myself again I'm doing height minus arm span. I can drag this row further over. You can see that. And then now I'm going to type some spreadsheet commands, equals average. So I've got data sitting in C2 down to C16. Hit enter. And then equals STDEV. Remember, I don't want any of the fancy standard deviations, just STDEV. And it's C2 down to C16. And like I said, just by counting, I see I have 15 rows of data. Okay, so I'm going to need that then to carry out the 9 steps of a test for a claim. I reminded you I'm in section 8.3. These are paired dependent samples because this is 2 measurements on the same person. So I'm getting these paired dependent differences to analyze. So you guys go ahead and write out all 9 steps of a claim. Look at the model problem in the notes so that you can fill that in. Okay, now once I do that hypothesis test, I've got some extra stuff here I want you to add because I'd like to work in the spreadsheet, not on my calculator, working in the spreadsheet to get a confidence interval. By the way, filling in these 9 steps, I assume at some point you're going to use your calculator. But over here, I'm going to just do the confidence interval on my spreadsheet. So I've asked you to keep on typing in cell E5 through F9 this stuff. So let's type confidence level, T critical value, lower margin of error, lower bound, and upper bound. So this is 0.95. Now for my t-critical value, there is a spreadsheet command for that. So since I have a 95% interval, remember I have 0.025 in each of the tails. So if I want my t-critical value to come out positive, I'm going to need to type equals t.inv. And I'm going to say that my left tail area is going to be at 0.975. And then I have to type degrees of freedom. So remember, I have the sample size already sitting in cell F4. So I'm just going to type F4 minus 1. Okay, so there's my t-critical value. And for margin of error, if you follow the notes, I need to multiply the t-critical value times the standard deviation for the differences over the square of the sample size. So that means I need the value that I just got that's now sitting in F6, so equals F6. And then I'm going to multiply that by the number sitting in F3, which is the standard deviation. And then I'm going to have to divide that by the square root of the sample size, so SQRT, and the sample size is sitting in cell F4. Perfect. All right. And then for the lower bound, I need to go back to my mean and subtract the margin of error, and back to my mean and add the margin of error for upper bound. So if I go back to the mean, it would be equals F2, take away the number I just got in F7, and then equals F2 plus F7. All right, so I got a lower and an upper bound at 0.27 and 5.88, for which I can now write a sentence to interpret my confidence interval for the mean difference. I'd be writing something like, I'm 95% confident. Notice I got two positive endpoints. So I'm 95% confident that the mean difference, height minus arm span, is between 0.27 and 5.88. Or in other words, that person's height tends to, on average, is 0.27 to 5.88 inches greater than the person's arm span. Okay, that's a pair-dependent confidence interval. All right, now a few things about making connections. So the bottom over here about making connections. My two hypotheses, I'm going to write those down. And I would have had an HO that mu sub d equals 0, and an HA that mu sub d differs from 0. And I'm pretty confident that without doing it, my test was going to say fail to reject HO. I would have been pretty confident of that, just seeing the histogram of the differences. And now notice that my confidence interval that I would write down, that I would just have written down in this chart, has both positive endpoints. So when I go to answer this question, is 0 inside or outside the interval? Well, clearly it's outside. 0 is not one of the values in the interval. So the connection is, well then how would I know if I only did the confidence interval that I could make the same exact decision that I did in the hypothesis test? So I would like you to think about that. Explain how the inference made for the confidence interval estimate and the decision for the hypothesis test are consistent. I walk away thinking the same thing, that whether or not I rejected HO and whether or not zeros in my interval are somehow related to making a consistent decision. So you do your best to explain that on the bottom of page 14. All right, that's task 8 project work.